Hi kids, warm greetings to you all. Welcome to my channel. Hope everyone is safe and secure. I believe all would have watched mostly all the 3 modules and enjoyed it. Today we are going to see the module 4, that is the last module of this lesson, Matter Around Us. In this module we are going to learn what are solutions, types of solutions, Brownian movement, Tyndall Effect, differences between the types of solution, emulsions and types of emulsions. Watch and enjoy. Solutions. A solution is a homogeneous mixture of 2 or more substances. In a solution, the component which is present in lesser amount by weight is called a solute, and the component present in larger amount by weight is called a solvent. In short, the solution can be formed as follows: solute plus solvent, it gives solution. For example, salt plus water, we will get salt solution. In this, the solid part that gets dissolved is called a solute, example is a salt, and the liquid part that does the dissolving is called a solvent, example water. Types of solution. Based on the particle size of the substance, the solutions are divided into 3 types. They are true solution, colloids and suspension. What are the differences between true solution, colloids and suspension? The major difference is the particle size. In fact, interconversions of these mixtures are possible by varying the particle sizes by certain chemical and physical methods. How do you identify the given solution is a true solution, colloidal solution or suspension? Let's see it by an activity. Take 3 beakers and in each beaker add 1 teaspoonful of sugar, starch and wheat flour. Add 100 ml of water and stir it well. Leave it aside for about 15 minutes. We can see that in a case of the sugar, we get a clear solution and the particles never settle down. This mixture is called a true solution. In the case of starch and water, we get a cloudy mixture. This mixture is called colloidal solution. In the case of wheat flour mixed with water, we get a very turbid mixture and fine particles slowly settle down at the bottom after some time. This mixture is called suspension. Children, shall we see what a true solution is? A true solution is a homogeneous mixture of 2 or more substances whose composition can be varied within certain limits. A solution has a solvent and the solute as its components. The component in the larger amount is a solvent and the component in the lesser amount is a solute. Example, solution of salt in water, solution of sugar in water, iodine in water and soda water, etc. Properties of true solution. True solution is a homogeneous mixture. The particles cannot be seen by the naked eye. The solute particles cannot be separated by filtration. The solute particles do not settle down and the solution is stable. The particles do not scatter the beam of light passing through it and the path of the light is not visible in the solution. Some common examples in day-to-day life are sugar syrup, soft drinks, iodine in alcohol and copper sulfate solution. Colloids. A colloid is a mixture that has properties of both a solution and a suspension. The particles are dispersed throughout, but they aren't heavy enough to settle out. The particles can't settle, but they are large enough to scatter light. Unlike the suspension, a colloidal solution cannot be separated by filtration. Example, milk, mayonnaise, jelly and whipped cream. Some common examples of colloids are milk, mayonnaise, whipped cream and jelly. Classification of colloids. Colloids are classified into 8 types based on their physical state. Already we knew that a colloidal solution is a heterogeneous system consisting of the dispersed phase and the dispersion medium. The dispersed phase or the dispersion medium can be a solid or a liquid or gas. Classification of colloids based on the dispersion phase and the dispersion medium. First one, dispersed phase. It is a solid. Dispersion medium. It is also a solid. The name of the colloid is solid sol. Examples are alloys, gems and colored glass. Number 2. Dispersed phase is a solid and the dispersion medium is a liquid. Name of the colloid is sol. Examples are paints, inks and egg white. Number 3. The dispersed phase is a solid and the dispersion medium is a gas and the name of the colloid is aerosol. Examples are smoke and dust. Number 4. If the dispersed phase is a liquid and the dispersion medium is a solid, then the name of the colloid is gel. Examples are curd, cheese and jelly. Number 5. If the dispersed phase is a liquid and the dispersion medium is also a liquid, then the name of the colloid is an emulsion and the examples are milk, butter, oil in water. Number 6. If the dispersed phase is a liquid and the dispersion medium is a gas, then the name of the colloid is aerosol and the examples are mist, fog and clouds. Number 7. If the dispersed phase is a gas and the dispersion medium is a solid, then the name of the colloid is solid foam and the examples are cake and bread. Number 8. If the dispersed phase is a gas and the dispersion medium is a liquid, the name of the colloid is foam and the examples are soap lather and aerated water. Tyndall Effect. When a strong beam of light is passed through the colloidal solution, the light is scattered by the colloidal particles. This scattering of light is called Tyndall Effect. The illuminated beam of light or cone formed by the scattering of light is called Tyndall beam or Tyndall cone. The path of the light is visible when viewed from the direction at right angles to that of the incident light. Now we are going to see the very important property of the colloidal solution. Yes, it is nothing but Brownian movement. When a colloidal solution are viewed under the powerful microscope, it can be seen that colloidal particles are moving constantly and rapidly in zigzag directions. The Brownian movement of the particle is due to the unbalanced bombardment of the particles by the molecules of the dispersion medium. Brownian motion. The first evidence that matter consists of tiny particles in motion was given by the English botanist Robert Brown. When Robert Brown was studying about the pollen grains suspended in a liquid using a microscope, he discovered that the pollen grains were dancing to and fro in a random manner. Similar haphazard motion can also be observed when small colloidal particles suspended in a liquid are examined under the powerful microscope. The zigzag movement is due to the unequal bombardment of the particles and the molecules of the surrounding medium. This irregular motion of suspended particle is referred as Brownian motion. We shall study about the movements of the large and the smaller particles suspended in liquids. Let us first look at the isolated large particle A suspended in a solution. The number of molecules hit the particle A from all sides. On an average, the impact from all the sides cancels out. So, the resultant force on the particle is 0. Now, observe the particle B, which is very small. Particle B is hit by the less number of molecules. Moreover, it is not hit equally from all sides. Due to this, there is a resultant force. This resultant force alters the direction of the particle B. When particle B moves, the direction of the resultant force also changes, resulting in a zigzag motion. Let's understand the Brownian motion with the help of an experiment. Fill the hollow glass tube with smoke particles. Place it under the low power microscope. Simultaneously, illuminate the cube with light source. We observe that the smoke particles appear as bright as the particles in all possible directions, in a contrast to the black background. This is the experimental evidence of molecular motion of particles or Brownian motion. Now, shall we see the differences between the types of solutions based on their properties? The first property is particle size. The particle size of the suspension is greater than 100 nanometer, and the particle size of the colloidal solution is between 1 to 100 nanometer, and the particle size of the solution is less than 100 nanometer. The next property is filtration separation. Filtration separation is possible for suspension and it is impossible for both colloidal solution and solution. The third property is settling of particles. The particles of the suspension settle down on their own, and the particles of the colloidal solution settle on centrifugation, and the particles of the solution do not settle down. The next property is appearance. Suspension are opaque in nature. Colloidal solutions are translucent or semi-transparent, and the solutions are transparent in nature. Next property is Tyndall Effect. Tyndall Effect is shown by suspension. Colloidal solution shows Tyndall Effect, and the solution does not show the Tyndall Effect. The next property is diffusion of particles. The particles of the suspension do not diffuse, and the particles of the colloidal solution diffuse slowly, and the particles of the solution diffuse rapidly. Brownian movement. Suspension may show Brownian movement, and the colloidal solution shows Brownian movement, and the solution may or may not show the Brownian movement. The next property is nature. suspension is heterogeneous in nature and the colloidal solution is heterogeneous in nature and the solution is homogeneous in nature. Emulsions. Shall we discuss about the topic emulsions and the types of emulsions? Let's first look at what are emulsions. Definition for emulsion is: emulsions are the colloidal solution in which both the dispersed phase and the dispersion medium are liquids. Emulsions are liquid-liquid colloidal system, that is, the dispersion of finely divided droplets into another liquid. It may be noticed that any two immiscible liquids form an emulsion. Look at the example. Milk is a naturally occurring emulsion in which the particles of the liquid fats are the dispersed phase and the dispersion medium is water. Emulsion is generally unstable and the two liquids may be separated out on standing for some time. When we notice that oil and water can be easily separated out after standing for some time, they form different layer after standing for some time. To form stable emulsions, small quantities of certain other substances are added during their preparations. The substances which are added to stabilize the emulsions are called emulsifier or emulsifying agent. Some of the examples are gums, gelatin and soap of different form. Let's discuss about what is emulsification. The stabilization of the emulsion by means of an emulsifier is called emulsification. Our next topic is types of emulsion. There are two types of emulsion. The first one is oil in water type emulsion and the second one is water in oil type emulsion. Let's first discuss about oil in water type emulsion. In this case, oil acts as a dispersed phase, that is in small amount, and the water as a dispersion medium, that is in excess amount. Examples: milk is an emulsion of soluble fats in water. Such type of emulsions are called aqueous emulsions. When we see oil is dispersed in water, here oil acts as a dispersed phase and the water acts as a dispersion medium. Next type is water in oil type emulsion. In this case, water acts as a dispersed phase and the oil acts as a dispersion medium. Examples: butter and cold cream. Such type of emulsions are called oily emulsions. Look at the picture. Water is dispersed in oil and the water acts as a dispersed phase, whereas oil acts as a dispersion medium.